Today we're going to look at graphing a piecewise defined function. And what a piecewise defined function means is that we're going to have more than one rule to apply, and it will depend on what the value of x is. It'll say if. And if x is within a certain range, like for example, if x is less than 3, we'll apply this rule. We'll multiply x by 2 and then add 1. But if x is more than 3, then we're going to apply a different rule. And what it means is we're going to have two separate lines. And this particular line on top will only exist, this will only exist to the left of 3. And then the other one, 1/2 x minus 3, will exist as long as we are to the right of 3. So let's take a look at the first problem here. And we can see that we have two functions. The first one just says y equals 0. Well, y equals 0 is it's just a horizontal line at 0. So y is 0 all along the axis. And then this x minus 3 is a line that starts at -3. We'll go like this. And that's fine. That's x minus 3. And then y is 0. I'll draw it in red. Y is 0 is this horizontal line. But the lines have boundaries, and the boundary is right here. The boundary is at x is 1. And so I'm going to just put a little line. I'm going to put a dashed line at x is 1. This is where the function switches. So at 1, we change rules. And it's important then to decide which one is a dot and which one's a circle. I can see that this one is greater than or equal to 1, so that's going to be a solid dot. And it's going to be a dot on the 1 when this equation is happening, y is 0. So here's the y is 0 function. And when I get to 1, it's going to be a solid dot right there. In fact, I'll go ahead and change it to red. So there's going to be a solid dot, and that means to the right of this, nothing exists. To the right of this, I'm going to go ahead and take it away. I just took away the whole thing. And that's actually maybe not the worst thing in the world. So it only exists to the left, and its border is at 1. That means that for the other line, x minus 3, which has a y-intercept, you know, it's y equals x minus 3. To graph that means it has a 1/1 slope, and it starts down 3. So that's why I went down 3, and then I went up 1/1. That's why this is its slope. But look, it doesn't exist back here. It starts right there. It starts at 1, and we know that because it's not underlined, it's going to be a hollow circle. So I'm going to go ahead and take my eraser and take away that line, and I'm going to redraw it from the correct starting point. So it starts there, and it goes up 1/1. And that looks like that. And you'll notice that it's still a function, because when I get to 1, I still apply this rule of 0, but the moment I get a little bigger than 1, I jump down here and I apply this different rule here, which is y equals x minus 3. So this graph right now is an appropriate representation of that piecewise function. Now let's take a look at another problem. We're going to graph this one. First of all, I'm not a huge fan of how that particular function right there looks. I might rewrite it and say negative x minus 3. And that means negative 1/1 x and minus 3. And this one is y equals x plus 3. So there's our two lines. And the boundary is at -2. So I'm going to go to -2, and I'm just going to make a dotted line, because this is where the function switches. And it's a lot easier to do this on a whiteboard or a graph and then just transfer it onto a digital platform, have it drawn correctly already. Let's take a look at the top one, negative x minus 3. So I'm going to start down there at -3, it's right there, and then negative x, which is a -1 slope. And I'm just going to go ahead and put the dots on the graph. This is what it looks like, and I'll take away the ones I don't need. And remember, it keeps coming down this way. And now let's go figure out where that exists. So this is negative x minus 3. That one's graphed. It only exists when x is less than -2. So over on this side of the dotted line, this graph exists, which means these dots that I put down here, I'm going to go ahead and take them away. I don't need them. So I'm going to take away these dots. They don't exist in this piecewise function. They only exist to the left of -2. And I notice that it's underlined. So it's going to be a solid dot. So this right here becomes a solid dot. And then there's negative x minus 2. There's that negative 1 slope. Let's go graph the other one, and I know it's going to be a hollow circle. And it's at x plus 3, so plus 3. I'm going to graph it. I'm going to do this in red. So plus 3 is right there, and it's got a 1 over 1 slope. So up 1 over 1, up 1 over 1. But I got to get back to the starting point. Remember, it starts on the green dotted line. So I'm going to work my way backwards, and right there is where it's going to start. And I'm just going to go in and include that as a hollow circle, because I know it's a hollow circle because it wasn't underlined. It was just greater than. And then I'll draw this dotted line. We'll extend it all the way out to the edge, and there you go. So it's really important too is whenever we have a dot somewhere, we're going to have a hollow circle right above it. Because it still has to be a function, and we can't have gaps in the domain, meaning that every value of x has to be covered. So wherever there's a dot, there has to be a circle. Let's go to the last question, which shows up on your problems, and it started asking you questions like, what's the value of f of negative 6? Really simple, honestly. This is about f of x. So what they're telling us is, if x is negative 6, what's the value of the function? So that just says, let's go left 6. It's right there, left 6. I'm going to read up, and the value of the function is 3, because that's where it hits out there. So the value of f of negative 6 is 3. The value of f of negative 3, well, we go to negative 3. They're asking you this because they want you to know, which rule do we apply? Well, we apply the one with the solid dot, not the hollow circle. And in this case, the value of negative 3 is 0, because it's actually on the y equals 0. It's not even up. So the value of f of negative 3 is 0. And then the value of f of 0 is right here. And we'll read up until we hit the line, until we hit the function, which is a 4. So that's it. Hopefully that makes a little bit more sense.